So hair is made of protein, and hairs are quite likely to be found at crime scenes, particularly violent scenes where hair may have been pulled out forcibly. Now when you look at a hair, it's just a hair, but actually hairs are quite complicated. So this is what a hair looks like when it's, for instance, growing out of your head. The hair grows out of a root, which is inside the follicle, and it's inside the follicle that it is nourished by blood from blood vessels. And then the hair grows out through the skin, but the hair is not a single item. It's actually made up of different components within the hair. Now, the growth of the hair. When hairs start growing, they are inside the so-called anagen phase. This is the growth phase, and this can last some years. Now, in a violent incident, if a hair in the anagen phase is pulled out, for instance in a fight, then typically it's ripped out with the root of the hair, and the root of the hair will contain DNA. And this is, of course, extremely useful for identifying whose hair it is. Well, after a few years, the hair stops growing, the growth slows and then stops. This is the catagen phase. It's a transitional phase after the anagen phase. Then, when the growth has stopped and the root shrivels up, the hair can fall out. This is called the telogen phase. So hairs that naturally fall out in the telogen phase, and these of course are the hairs that collect in the drain of your bathtub, these are much less useful for forensic purposes because they don't contain very much DNA at all. So let's look at the structure of a hair. The outside of the hair is called the cuticle, and this often, for instance, looks scaly, but by inspection of the cuticle, it's possible to identify the species from which it came. Inside the cuticle is the cortex, and the cortex contains the pigment granules. So it's the cortex that controls your hair color. The pigment granules can be examined under a microscope, and you can determine the color and the size and the way they're distributed and how closely they're packed in. And that's useful information. And in the very center is the medulla. And again, this is particularly useful for identification of the species. So here, for instance, are three different hairs. There's the cuticle, and you can see between human and dog and cat, they're quite different. Also the medulla. You can see the pattern for the human, the dog, and the cat hair are quite different. So from microscopic inspection, you can determine whether a hair is human or from a different animal. Now, how do we individualize a hair? Well, in the ideal situation, there will be sufficient tissue from the follicle that you'd get enough DNA to identify whose hair it was. And this is typically true when that hair has been pulled out. If that is not the case, then it is necessary to rely on comparison. For instance, suppose you have a hair from a crime scene and a hair from a person, a suspect, or from a corpse. Maybe the guy has been murdered. You can take the hair from the crime scene, the hair from the body or the person, and you compare them under the microscope. This is not done by a scientific hair comparison machine. It is done by an experienced expert. So the judgment as to whether those two hairs come from the same head is the opinion of an expert. And like all human activities, it can be wrong. So for instance, in a survey done by the FBI, 11% were misassigned. So we cannot say that hair examination and comparison is particularly accurate. Now, hair analysis also gives us another opportunity. We said in the first lecture that forensic science enables us to reconstruct what happens in the past. The hair, your hair, contains a record of the chemicals that were in your body in the past. If you consider a hair growing out of your head, typically hairs grow at about ½ an inch, that's 1.25 centimeters per month. As the hair grows, it's nourished by those blood vessels, but any extraneous chemicals in your blood will also be deposited in the hair. As the hair grows out, those chemicals will be locked into the hair. For instance, a bar, a disreputable bar, is raided by the police. The people in the bar are required to give urine samples. Someone is found to be positive for a drug, let's say it's ketamine. They're questioned by the police, and they deny that they're a ketamine user, and they say that maybe somebody slipped the stuff in their drink that evening. How can we find out whether they're telling the truth? You can do it by hair analysis. Take a hair sample, cut off at the scalp. At the scalp will be the newest hair. Cut it into segments, analyze the segments. If that person's telling the truth, then there will be no ketamine in the hair. But if you find ketamine relatively evenly distributed along the hair, then it tells you that person is a habitual user and they're lying. So hair analysis helps us determine and reconstruct the past in terms of a person's chemical exposure. In the case of ketamine, we're determining whether someone willingly exposed themselves to that chemical. It can also tell if someone was unknowingly exposed to a chemical. So Robert Curley died in August 1991, and analysis of his body fluids showed high levels of the toxic element thallium. And thallium, of course, is an element that we'll meet again in a lecture on toxicology. Now, Curley had done kind of maintenance work, handyman work, and he had worked doing this kind of thing in a university chemistry laboratory. So an obvious suspicion is that he was exposed to thallium in that chemistry lab. And sure enough, there was a bottle of a thallium chemical in that lab. But it didn't add up, because the other people working in the lab did not show any traces of thallium. So when his wife tried to sue that university, the case didn't go anywhere. Now, further investigation showed that it was not only Robert Curley who'd been exposed to thallium, but low levels of thallium were detected in his family members, and most significantly in a thermos flask that he'd used to take a drink with his lunchbox. And interestingly, he was insured for $297,000. Well, this adds up to a lot of suspicion, and his body was exhumed. And in order to reconstruct his past exposure to thallium, samples of hair were taken and analyzed. And his hair was long enough that they could work out his thallium history for the last 10 months. Okay, his oldest hairs, his longest hairs were 10 months old. And it turns out that he had been exposed to thallium over a period of 9 months. So he'd actually been exposed to thallium even before he worked in that university chemistry lab. So there were low levels, sometimes 0 levels of thallium along the length of this hair almost, and a relatively high dose just before he died. So with this evidence, his wife confessed and she was convicted of his murder. One of the best-known fiber cases is the case of Wayne Williams. And this is in Atlanta, Georgia, back at the end of the 70s and the beginning of the 80s. So starting in July 1979, the bodies of young black men were found dead in the woods of that area over a period of several months. And it seemed likely that these murders were linked to each other. And when the bodies were examined carefully, the investigators found fibers, and they found the same fibers on different bodies, identical yellow-green or violet fibers in the clothing of the victims. So microscopic analysis showed that some of these fibers were quite unusual shapes, and it took the police quite a while to track down the manufacturer. Now, in early 1981, a newspaper picked up this story about the fibers and published it. Remember, the fibers were found in the clothing of the victims. So after that newspaper article, further bodies were found, but they were stripped naked and they'd been dumped in the river. So clearly the murderer read the newspaper. After the bodies were found in the river, the police started to watch the bridges. In May, 2 a.m. one morning, police officers watching one of these bridges heard a splash. And on the bridge, they found someone who they arrested, and it was Wayne Williams. A couple of days later, the body of the victim, a young man called Nathaniel Carter, was found downstream. And yellow-green fibers, identical to those found on earlier victims, were found on his body. Not in his clothes, because he didn't have any, they were in his hair. So now the police have a suspect, and they also have forensic evidence in these fibers. So naturally they searched Wayne Williams' house, and they found he had a yellow-green bedroom carpet, and the fibers from that carpet matched fibers found on 10 of the victims. Now you can make an argument here that Wayne Williams will not be the only person in Atlanta with that color or type of bedroom carpet. So by now the police had been able to track down the manufacturer, and they've been able to find out how much of this carpet had been sold. And they could calculate that this carpet would be present in something like one home in each 8,000 homes in the city of Atlanta. To put that in perspective, at that time in Atlanta, there was just over 600,000 homes. So the odds are quite good, but not overwhelming. However, the police are not relying on a single kind of fiber, because they also found violet fibers on 12 of the victims. These matched the fibers of a bedspread in Wayne Williams' house. In addition to that, hairs from Wayne Williams' dog were found on 11 of the victims. Fibers from his car carpet were found on 8 of the victims. So one single kind of fiber is not overwhelming evidence, but when you take all this fiber evidence in its totality, it appears to be very strong. And Wayne Williams was convicted and remains in prison to this day. our final case about fibers is the case of Sarah Payne. Sarah was 8 years old when she disappeared, and her body was found 2 weeks later out in the countryside, found by a dog walker, substantially decomposed and could only be identified by DNA. The suspect was a man called Whiting. During the investigation, Whiting was actually in prison for a completely different offense, dangerous driving, and that gave the police plenty of time to really search his van. Fibers proved to be very important in this case. They found many fibers on the strap of Sarah's shoe. This is one of those shoes which uses a Velcro strap, and fibers get tangled in the Velcro very easily. So in the Velcro strap, they were able to find 350 fibers. But most of those fibers had no evidential value at all because they were fibers from her own clothes. However, amongst those 350 fibers, they found 4 fibers which came from a red sweatshirt owned by Whiting. Now, how did they know that the sweatshirt was Whiting's? Because they could get DNA from the sweatshirt, and that proved it was his. In addition, they were able to find fibers in Sarah's hair, and these variously matched the sweatshirt, some socks, and the van seat of Whiting's van. Further, on searching the van, they found 40 fair hairs, the same color as Sarah's hair. From those 40 hairs, one of them gave a DNA result, and the DNA of the hair matched Sarah's DNA. All this fiber evidence, the fibers from the clothes and the hair, is very strong evidence linking Whiting with what happened to Sarah Payne. One aspect of this story is the enormous effort it took to build a case. It's not like CSI on television, where the case can be solved in 25 minutes, including commercial breaks. An enormous number of scientific tests were done. The investigation involved an enormous number of people. It took a very long time and cost a great deal of money. The result is that Whiting was sentenced to life in prison. So to sum up, if we want to identify fibers, we can use microscopy and spectroscopy techniques. We can use spectroscopy on both the fibers as well as any dyes or other chemicals that are in the fibers. When it comes to hair, we can use microscopy to determine which species that hair came from, and by comparison, we can get some idea of whether the hair came from a particular individual. Though, of course, comparison of hairs is far inferior to DNA technology.